Our subtraction in 2's complement. So this is an easy one because the values themselves are lending themselves to borrowing and other subtraction methods. But we're going to try to subtract by adding the value in 2's complement as a negative number. Starting with the 70, 70 would be a 64 plus another 6. So I'd put a 4 and a 2 here. So I'm going to call 70 0100 on the top side and 0110 on the bottom 4 bits, and that's my 70. Now I'm going to do the same thing with my 24. We'll erase these, and 24 would be a 16 and an 8. The rest of these would be zeros, so my value for 24 would be 00011000. Now we're going to try to add this as a negative number and combine them in 2's complement. Now since this is a positive value, the 2's complement method for drawing out a positive value is just that same binary value. We're not going to change that at all. However, this one is negative, so my technique is to flip all the bits. This is going to be 1110 as I flip each one of these around. This becomes 0111. So the value that I'm going to add to this is 1110. Oops, I made a mistake here. I forgot to add the 1. Sorry, almost did that. Make a mistake here. So this would be 1110, and this would be 0, carry over, 0, carry over, 0, carry over, and then 1. So I'm going to put this value over here. So there is a 24 in 2's complement as a negative value. Then what we're going to do is add them together. They're both in 2's complement now, even the positive number. So we're going to get 0, 1, 1, 1, a 0 here, a 1 here, a 0 with a carryover bit of 1, and a 0 with a carryover bit that goes on to the next thing, which we kind of just dump. Okay? Now, since we have a value of 0 in the front of this, this is indicating that it's a positive 1. So even though the number in theory is still in 2's complement, switching it back to regular binary is as simple as just saying, well, it's the same in regular binary as it is in 2's complement if it is a positive number. So let's just go ahead and interpret that as a value. This is a 32, and then this is an 8, a 4, and a 2. So I have a total of 46 as my value when I add the 3 of these together. Now we should be able to come over here and ask ourselves if that's true, because in theory we should be able to subtract, and we get 46 for that value. So our technique was switch all the digits if it's negative. If it's negative, switch all the digits, then add 1, get the 2's complement value, and then we just do an ordinary addition between the two of those. The value that comes out of that is a 2's complement number, so it has to be changed back into binary, but since this is registering as a positive value, it registers as the same number in binary. Now that won't be the case if it comes out to be a negative value like the next example, but in this case that's the way it worked out. So when I test you on this, I want you to show all your work, including how you're switching this into 2's complement, because that's part of the program to be able to use that.